During our discussion today, we will review the steps necessary to add a motion device into Studio 5000 programming and the tools available to make that process quick and simple. Let's jump into it. Before we get started, let's get to the basics. Why would you use an add-on instruction? With add-on instructions, you can create new instructions for sets of commonly used logic, provide a common interface to this logic, and provide documentation for the instruction. Add-on instructions are intended to be used to encapsulate commonly used functions or device control. Add-on instructions are often referred to as AOIs. The key reason to implement add-on instructions are to reuse code. Once the AOI has been created, it can be used over and over again throughout the program. This can help reduce overall program size and simplify the logic. They can provide an easy-to-use and understand interface. When the AOI is added to the logic, it will appear as a function block with each data input field defined and named, eliminating the guesswork of what data needs to be entered or what data is being displayed within the AOI. You can export and import AOIs. Once the AOI is created, it can be shared by exporting it to a file. Or you can import AOIs that you have used in a previous program or import AOIs from the product manufacturer, which are provided to make the path to product integration straightforward. Some assumptions we're going to make today for the sake of expediency. First, this review is about third-party products. Adding and programming Rockwell devices in Studio 5000 will look vastly different. We're going to assume that the device we're talking about communicates to the PLC via Ethernet IP. We assume that the manufacturer can supply proper Ethernet IP and setup data. That's typically going to be done using downloads from the manufacturer's website. Could be simple as a simple program, sample programs. It could be add-on instructions separately, but it would be provided by the manufacturer themselves. We're assuming that you're running version 20 or higher of Studio 5000 because some of the features and functions we're going to talk about do not work on older versions. And we're going to assume that you're familiar with adding devices to an Ethernet IP network. Some of the more basic products use a generic EDS where the user has to set up data manually. This would be adding things like assembly instances, the data words that are being transmitted back and forth through both input and output, and in some instances, configuration, and also the data type. Sometimes that can be confusing. You got to have a manual in front of you to do that. So using a custom EDS really simplifies that process. That creates the properties pane unique to the particular product, as you see here on the screen. The only thing you need to do to add that device to the network is give the product a name and enter the IP address, and you're all set. So setup is simpler, and as you're going to see on the following slides, it does provide expanded product properties. We're going to have configuration tags. Within these configuration tags, we store the motor configuration within the PLC. We no longer have to configure offline or have some sort of separate HMI or interface to do the configuration of the device and store it within the device. And that means it simplifies in the field replacements. If for some reason the product fails, you take the new product out of the box, give it an IP address, plug it into the PLC through the network, and all that data, once it's powered up, is stored and downloaded into the product, no longer having to do some sort of external configuration and hoping the person who's doing the maintenance understands how to do that process. You can mix and match data types within the EDS. As you can see here, this particular EDS uses both input and double integer data within the structure, which makes it a lot easier to display the information that's being transmitted in a meaningful manner. And each product has a unique data type, as you see here. So anytime we have a product that we add through a custom EDS, it's going to have a unique data type. And that means each one of those data types is associated with an add-on instruction set, which we'll talk about in a little bit. So now let's take a look at those data tags that got created. As you can see here, for both the output data and the input data, we no longer have just zeros and bit numbers and things of that nature. We actually have meaningful names. And those names are associated with the particular function of that bit. So for example, if we're doing programming and we wanted to do things like monitor within our logic, is the axis stopped? Is it moving in a particular direction? We simply go through those data tags and we can see exactly what that bit is. Instead of just being, say, input word 0, bit 0, it now has a tag name associated with it. So when someone's looking at logic, maybe it's doing some maintenance or making some improvements to the program, they know exactly what that bit is supposed to be doing. So it makes troubleshooting a lot easier. So using product-specific AOIs, one of the nice things is you only need to import the necessary AOIs from the product library. So for example, what we're looking at here is a product library from a particular manufacturer, and you can see they've created an extensive set of add-on instructions for each type of move type and each type of function that that particular motion product can execute. We might not necessarily need every single one of those, so we're only going to drag and drop and add into our PLC logic those add-on instructions that we need. Once we've done that, we'll have a tree, as you can see here, that would be for those particular add-on instructions that we've added to our PLC program. And then when we want to add that to our logic, we simply grab that AOI, drag it over to the logic to a rung that we've created, and you'll have an add-on instruction that looks something like this. As you can see here, each particular add-on instruction, when we bring it into our logic, it's going to be given a name. In this case, we gave it a pretty simple name, AOI relative move, but we may have several relative moves that we need to do, so we may call it relative move 1, relative move 2, relative left, relative right, whatever we need to call it. So it's a lot clearer, it makes it a lot easier to program, but that also means we can now share AOIs and we can reuse that AOI multiple times within the logic because they each have their own unique data tag. And as you can see, once we've created that AOI, you see the data types or the data that it's looking for. In this case, it's looking for target position, program speed, accel, decel. Those can be entered as either constants or, as we've done here in the sample, they can be added as variables. One of the benefits of using it as a variable is it allows us to go to an HMI, make changes to those values as we see fit or as we change particular setups on the machine. Now, before we move on to the next step in AOI development, let's take a quick walkthrough on how it's done within the Studio5000 programming environment. Okay, as you can see here, I've opened up a program, a basic start-off point for a Studio5000 program, where we're going to be adding a couple of devices using both custom EDSs and standard add-on instructions. I know we were going to just kind of gloss over it, but for those of you who aren't familiar with or new to using EDSs and custom EDSs, the method for adding a device to the EDS tree starts with importing the EDS, and that's done here under the Tools menu. You click on that tab, and you have an EDS hardware installation tool. That will open up, and once that opens up, we simply click Next so we can start doing what we need to do, and we just want to simply register a device. So we're going to click Next. We're going to browse for that device. Now, I've already downloaded the devices onto my PC, so we're not going to go through that process. We browse, we look. One of the products that I want to add here is the AMCI S&D 17E2, so I click on that. Click Open. Click Next. It's going to confirm which one that I've selected and we'll be adding to the system. Click Next. You'll see a little icon that comes along with it. So when I add it to the tree, that's the icon you'll see. Register the following device. Yes. next, and we're done. That's how simple it is to add an EDS. Adding add-on instructions isn't much more difficult than that. We simply come over here where it says add-on instructions on the left side of the screen, where we see add-on instructions. Click a right button on that, and it's acting up. Okay, so now we can do our add-on instruction selection here. We simply click right button, import add-on instruction. Again, already downloaded this, put it on my PC in a particular folder, named it as you would suspect, SMD17E2 AOIs. And there's a very large library here. I'm not going to select all of them. I'm only going to do one or two of them just for example here. One of the things with add-on instructions is you can only select one at a time. So each one you want to add, you got to do this process individually. You click open, confirm the file name, click OK. And when we come here, we can see the absolute move AOI. You can look here at some logic if you are so inclined. There's not really a reason to here because it's already been done for you. They're thoroughly tested. There's not really much you can do there to improve upon the AOIs as they exist without possibly causing issues along the way. Now that I've added my AOIs to the program, I'm going to add the motor to my network. So I come here, click new module, and there's a whole lot of products that will show up when adding a new module. Easy process here would be to deselect all the manufacturers and simply select the manufacturer that we're working with. The manufacturer we're working with here is going to be Advanced Microcontrols. They're right on top here, so easy to find. And then you'll see all of the EDSs available to us from that manufacturer. And we're looking for, in particular, the SMD17. So we're going to create a device for that. We're going to select that. We're going to come up with a pretty clever name here, call it SMD17E2 motor. Give it an IP address, 192.168.0.50, which is the number when it comes out of the box. Okay, we're all set to go. So we're going to add another device here just so the process continues as we are doing this. I'm also going to add, because my system requires both a NEMA 17 and a NEMA 23 motor, so we're going to add the NEMA 23 motor. We're going to create that. IP address 192.168.0.51, because obviously we can't have conflicting IP addresses. So we have that. So now we've added all the devices that I want to add to the network. So we're going to just close out of this. Now, if I want to, say, do an absolute move for the SMD17, just simply drag that over here. And then this is where we create the unique tag for this that's associated with this AOI in that particular command. So I right-click on it, select new tag, and it creates its own data type that's associated with that add-on instruction. We don't have to worry about any of that stuff. The only thing we have to worry about is naming it. So we're going to call it SMD17E2 absolute move clockwise. Create it. Now, part of the add-on instruction, and we use within the add-on instruction, is going to be some status bits. So we need to select which device we're going to be using to read those status bits. So just double click on that, get our pull down menu, and you'll see the different devices that we can select from for reading status bits. For this, we want the SMD17 motor input data, and we're going to start with status word 0 because it's going to want to read all 10 words the way it's set up within the structure of the AOI. And we're all set there. And rather than use variables and go through that process. I'm just going to use constants because it's going to be a little bit faster. So our target position, we're going to go to position 50,000. We're going to go with speed of 1,000 revs per second with an acceleration and deceleration value each of 100. Now we have to tell it which particular motor that we're going to. So we're going to go to the SMD17 motor and give it just a go button here. So we're going to say, call it first move, just why not? Great. And we have a rung that seems to be what it wants to be. So we're going to add another rung because now I want to do a move for the SMD23E2. And we're going to show you something here relatively quickly, just so we don't go through the whole process. But when I add this in, I have an absolute move here. So I'll just use that same one for the absolute move for the NEMA 17 for the 23. Now, when I come here and say, okay, what motor am I sending it to? It won't allow me to even select that motor. That's because when these EDSs are created, they have a unique data type, and that unique data type is associated with each one of these add-on instructions. So we can't use them. So what we would have to do, we'll get rid of that because we don't want to do that. So now we've got to come back over here to our add-on instructions, import add-on instructions, find the AOIs where we've downloaded them from for the particular motor. And we're going to add the same absolute move. Oops. Add a run. Add our AOI. And now, as you can see, we can now send it to that motor. So that means for each one of these products, if I have multiple products of different varieties, say it's a NEMA 23, a NEMA 34, or one is just simply an integrated drive, each particular one needs its own add-on instruction set. And you can see if you've got, say, 2 or 3 motor types doing several different types of moves, your add-on instruction set that's going to be part of that program is going to get pretty large. So it works, but it can be a little bit confusing for someone who's new to it, dragging, okay, I got to drag this one over for this one, drag this one over for this one. But steps have been taken to make that process a lot simpler and a lot easier and a lot more sharing amongst the particular product types. So instead of having multiple, we now can have one add-on instruction set for all of them. The next phase in the evolution of motion add-on instructions for third-party products is the concept of universal motion AOIs. And this is a concept that AMCI has created. AMCI has, in the neighborhood of a half a dozen different integrated motion products, each with its own set of add-on instructions. However, based upon what customer feedback is, and really just to make it simpler for customers to use all of our products, is AMCI has gone and created a universal set of motion add-on instructions. So regardless of what the product is, whether it's our integrated motors or integrated drives, whether it's AC powered or DC powered, it doesn't matter. It's the same set of instructions. We're no longer having to download multiple versions like we did in the previous slides in the previous PLC program. And what that does is it helps reduce our AOI assets. Again, one set, multiple products. And it works with any AMCI E2 motion product. And if the EDS file changes, no changes are required within the PLC logic. So some of the things that we've been leveraging within the PLC programming and how we made this happen is we've created a user-defined data type for both input and output data. And this allows the AOIs to work with multiple products. So individual product EDS does not need to change. So they still have their same unique data types. They still have the same grouping of data tags. that's unique to that particular product. So we're not having shared configurations, even though the products are different. Each one still has its own unique set. But the AOI set is shared. And as you can see, what we've done to create these and make them a little bit more universal, a little bit user-friendly, is we've made them look a little bit more like the motion instructions from Rockwell Automation. We now have more data tags available to us. We have a done bit, we have in process bit, and we have a process complete bit, which were not available with the other add-on instructions. Other benefits of the universal motion AOIs is they're future-proof. So they'll work with any motion product that exists now and ones that are created in the future. So, you know, as products get developed for integrated steppers, integrated servos, anything of that nature, it'll work. As newer products get released and use AOPs versus EDS files, they'll also work with AOP devices, which will help streamline logic. And because they look and program like standard motion add-on instructions from Rockwell, programmers that are familiar with doing that will have an easy time picking up on how the AMCI motion AOIs work. And we are the only Ethernet IP integrated motor that's allowed to supply custom EDSs and universal add-on instructions, which really makes us the right choice when your controller is a Rockwell Automation controller. Before we move on to the end of the presentation, let's jump in and see what those universal add-on instructions look like in Studio 5000. Okay, so now let's take a look at how we're going to add a device and also how we add the universal add-on instructions to our program. I've left the two motors that we were using in the previous one. If you remember, with those ones, each particular motor had to have its own add-on instruction set. With this, we'll show how each one can use the shared or universal add-on instruction. The first step in using the universal add-on instructions is to import those data types that we talked about in the previous slide. So just like we do with the add-on instructions, we come over here to data types under user defined, click in import data type. Now, again, we're making assumptions. You've already gone to the manufacturer's website, downloaded the necessary information to use these universal motion axis AOIs. Within that folder, when you downloaded it, you'll have folders that are labeled AOIs, data types, EDS files, so on and so forth. We're looking for data types. So we're going to click on the data type folder, and you're going to see two data types, one being the input data, which is the stuff that the motor's going to be sending to us, and the output data is the stuff we're going to be sending to it. So we're going to first select the input data, import that, click OK, and just like we did with the input data, we've done the same step with the output data. And as you can see here under user-defined data types, we have both the motion axis input data and the motion axis output data types. And you'll see why those are important to have in the next step when we start programming the add-on instructions. So let's go through our add-on instructions, import the motion AOI add-on instructions, as they're called. Double click there, and we're going to do a relative move in this sample, just like we did with the other one, where we did an absolute. This one will be a relative. So we're going to select the MAM instruction, which, if you're familiar with the MAM instructions, that covers both absolute and relative moves. So we're going to open that up. Give it a file, and it looks like we have already imported that. Let's see. Maybe I didn't select it. Hold on a moment. Yep, let's select that. Click open. It's imported it. And we see that the add-on instruction is part of our sequence of add-on instructions, the first of many that we'll be adding. But for this display, we're only going to be adding one. So now we want to do an absolute move with the SMD 17 and a relative move with the 23. So I'm going to drag over the add-on instruction to, oops, first we got to add a rung here to add that logic to. Come over here, grab our instruction again. Just like we do with the standard ones, each one has its unique name. So we're going to call this, what did I say, SMD17 absolute. Data type MAM associated with that particular instruction. Create. Now we have to go in through and fill in the blanks of the add-on instruction. So this is where the data types come into play with the universal AOIs. Instead of selecting the particular motor that we're sending it to, we have to select a particular data type, and that starts here. And the input data is associating it with a new tag. And that new tag, we're going to call this one SMD17E2 input data. Create it. And now this is going to go to new tag. SMD17E2 output data. And you can see this data type here is associated with the AMCI motion axis. It automatically assigns it that particular data type. So now for this one, we're going to be doing an absolute move. So we're going to put a 0 in here. Again, these could all be variables, and that would allow you to toggle between absolute and relative moves here, but we're going to just use constants. So we're going to move to a position of 20,000 at a speed of 5,000 steps per second. Acceleration of 100, deceleration of 100. And then we just, as you can see, it's accepted that data, and it doesn't really care, where that particular associated input data and output data is relative to as far as the product type is concerned. So now we want to do the same thing for the SMD23E2. Add a rung, drag over our instruction. And this time we wanted to do a relative move. So we're going to call this SMD23E2 relative. Again, data type, same as we used before, MAM. Create. Input operand, new tag. Name is going to be SMD23E2 input data. Tag. We want to do relative moves, so we select one. Position, we're going to go 50,000 steps at a speed of 1,000 steps per second. Acceleration of 100. 100. And it's that simple. So the final step in getting the data to go back and forth between the motor and the controller via input and output data is to then take those unique data types that we've created through those motors here, both the SMD17E2 data and the SMD23E2 data, to get that to send over to the motor itself. And that's done with a simple copy instruction. And I'll show how that's done here just for the 23, because the process is exactly the same for the 17. So what I want to do here is I want to find the copy instruction that we're going to be using to get that data over. And let's see if we can find that here quickly. File, we're going to use a synchronous copy. Grab that over here. Now the source of the data for the input is going to be the motor itself. So we're going to come here, find the motor, and we're going to start with the SMD23 input data. Click that. and we're going to select the very first word because it's going to copy 10 words. So we got to tell it which word to start with. Start with that word. And we're going to copy that to the SMD23 input data. Like the 10. And now any information that the motor is sending the controller is now being used in the PLC program through that input data. You kind of wondering yourself, why not do that within the AOI? Well, it really has to do with the fact that, we're showing a very simple example here with only one instruction, but we have multiple instructions. This reduces the number of copy instructions that we have to one, and therefore it kind of prevents situations where maybe something is overwriting somebody else's information, makes it a lot simpler. So then when it comes to the data we're going to send to the motor, we do a very similar process. We add a rung, do that same copy instruction. The source this time will be that SMD723 output data that we created. Oops. And the destination of that is going to be the motor itself. And that's going to be there. Again, 10 words. Done. And now we're moving data from our PLC program over to the motor. It's that simple. And as you can see, it really cleans up the logic, cleans up our programming by having shared add-on instructions. So it makes it really nice and easy to use and easy to program. Thank you, everyone that stopped in today to watch this video. If you have any other questions or would like more information on AMCI's motion add-on instructions or any of our other products that we offer, please visit our website at www.amci.com.